Hello everyone, today we're gonna solve the all positive full binary trees problem. This problem is basically we're gonna have to return all of the valid full binary trees with n node. A full binary tree is a binary tree with where each node has exactly 0 to children. So how can we do that? First of all, we're gonna consider the small test cases first. For example, if we have one node, we're gonna just return an node with 0. And if we have two nodes, so we cannot create any full binary trees from two nodes. So this one is valid case. We cannot create anything from here, so we will remove an empty array in this case. Then for three nodes, gonna have something like this. And for four nodes, we also cannot create anything. And for five node, so five node basically we can create from 0 and 3 subtrees. So let's say we're gonna have a new node right here, and we're gonna create a 5 node from a root. And how can we do that? We already know that we have a root like this, right? So the number of left node and the number of right node. So let's say above left plus with the number of right should be equal to n minus 1. So it should be equal 4, right? So let's say if we have the left node is a subtree with just one node, the right should have a subtree with 3 nodes. So the left one should be just one node, right? The right one should be this tree. So that's one case. And another case is that we're gonna have 3 nodes on the left side, and we're gonna have one node right side, node 3 node. And then basically we just need to connect the left node to this one and the right node to this one. Same thing here, we're gonna connect left node to this and right node to this. So that's basically the idea, and we're gonna do that in our DFS function. So first of all, we're gonna consider the n equal to 1 and n equal to 2. Have the case first. So if n equal to 2, we cannot create any subtree, so empty. If n is 1, we're gonna return uh, uh, we have to return a vector node 0. This look good. Yeah. Okay, and we're gonna have a vector I result right here, so that we can store all of the combination of left and right subtree. Then we're gonna look through all of the size for the left subtree. So let's say this is the left subtree size. We start from 1 to let I less than n minus 1, because we're gonna we're gonna leave one root node, so we cannot look until end, and we're gonna have at least one node for root and one node for right tree. So that's why we just look to n minus one right here. Then we increase the left. Then we calculate the number of nodes on the right side, right subspace, go to n, and we minus with the sign on the left one, and we minus with the sign on the root node. So it's going to be 1 for the root node. And then we're going to use this function to create left left size, and we also create the right side as well, and we need to store all of them to a vector. Let's say have a vector of left substrate, and we're gonna have the vector of right substrate, and then we're gonna write a function to connect the left substrate and the right substrate. Let's say just build tree function. Gonna have a left sub and right subtree, and we're gonna just return so we don't need to call it more. So we have a tree. We're gonna have a vector is f subtree, subtree as well. And then we're gonna have to look through all of the substrate, left substrate, then we're gonna create a new tree. Gonna be new node from root to left and right. So that's basically the idea. And we have to store all of the new tree. So I'm gonna just create a vector. Here is called tree. I'm gonna push this new tree into our store tree, right? Just tree, right? Finally, we're gonna return array. Yeah. And the the time complexity, of course, we're gonna look through all of the substrate. So it's part of n, and the space is to the power of n as well. And the topic for this problem is cost tree and recursion, of course, and pointer as well. That's all. Just I think this So we're gonna have to we still have to store all of the tree, right? Because we have a right here 0. Let's say this one is result is gonna duplicate the name to have a vector of a new tree. Go to this, gonna push all of the new tree uh, into our result. Better, and we're gonna return the result here. Perfect. Perfect, and that's all for this question. If you guys have any question, just leave it below and answer all of them. Thank you. Hope it helps.